Hello and welcome back. Now there is a new topic, which is the bending strain. First, the expression of pure bending. What is a pure bending? A pure bending where section is subjected only to bending moment without any other forces. As we can see, we have an overhanging beam. AB is being supported at point C and point D by hinge, two supports, and is being acted upon by vertical force going downward at point A, 80 pound, and similarly other force acting at point B, which is also 80 pound. Due to the equilibrium, sigma Fy should be equal to 0. We will find that we have a reaction Rc equal to 80 pound and also same value at D, which is equal also to 80 pound. If we are going to investigate this beam, we will find out that there is a bending moment acting on D in the clockwise direction. The amount for that bending moment is equal to 80 multiplied by 12 inch, which will equal to 960 pound inch. And the same case also happens at point C, where we have anti-clockwise moment, which is equal also to 960 due to symmetry, 960 pound inch. What about the shear force? The shear force for the portion CD, we have 80 pound coming as positive, going from B to D, then it's being cancelled by this amount. So from D to C there is no shear. Also in this example there is no normal force. So for the portion CD it is a case of pure bending, because this is a couple and the moment between C and D will be 960, which is negative and is hogging moment. In order to get a general expression for the strain, we assume that we have a beam AB, A dash B dash. Before this beam was having a section, and there was no deflection, but due to the application of couples M and M dash, bending moment start to sag. What happened due to sagging? That the lower portion get increased in the length, while the upper portion AB becoming contracted or having decrease in the length. In order to get an expression, here this AB contracted and this is expanded, so we have a neutral axe. This neutral axe is having length which is not unchanged. We draw a line here and take a perpendicular angle to the tangent here, and again another line perpendicular to the tangent here. These two lines will intersect and they will give us the center of curvature. Let us assume that the center of curvature is at point C. The radius of curvature is denoted by rho, which is the distance between C and D, and also between C and E. In order to get a general expression, we assume that we have plane JK, which is apart by distance y from the neutral axe. So the remaining distance will be rho minus y, and this is the y. We continue by our discussion, denoting the radius of the arc DE by rho, and the theta is the angle in between these two lines. The original length before the change was rho multiplied by theta. Due to the change, now we are examining this section JK, which is apart by y. We can see that the length now after the application of the moment becomes rho minus y multiplied of the theta, will give the length of this curved portion, which is the length after application of moment. So the strain will be L dash minus L. We can write that original length was rho theta minus y theta, and we get the delta minus y theta. So actually we are saying that rho minus y multiplied in theta deducted, and from which we deduct rho theta, so we will come to that expression minus y theta. This is the extension. If we divide by the original length, which is rho theta, we get an expression for the strain. We are saying that epsilon x equal to minus y over rho. The minus sign because we have considered that the y positive direction is coming upward, and this is x positive, but this, although this is y, is coming up as positive, but we have contraction here, so the strain here is minus y over rho. In order to get the stress, we multiply by modulus of elasticity, and the maximum value of the stress is denoted by sigma m, and by proportionality we find that y over c is equal to sigma x multiplied by sigma max. Thanks a lot and see you next time.